Good morning, everyone. Welcome to the Rescale webcast today. I hope you can hear me clearly. If not, please shoot me a quick note in the chat section of the GoToWebinar. We're going to get started here in just a second. I'll let a couple more people roll in here. I can see that there's quite a few guys on the phone. But today's going to be really interesting. We're going to go through fairly informally EDA and Cloud HPC with some really a very special guest today. So if you guys would just hang tight for 1 or 2 more minutes, we'll let some other people join, and then we'll get started. All right, let's go ahead and get this show underway. Okay, guys, so today we're going to do a bit of a podcast, videocast style. I was really encouraging our team to not sort of put everyone through sort of a standard boring webinar. So this is going to be a little bit more casual. This is going to be a little bit more fun, a little bit more interactive. So I would encourage anyone that has any questions during this discussion with Rich and I to go ahead and enter those into the GoToWebinar chat. We'll bring those right up live during the show. And so we can all sort of get the most value out of this as possible. So before I get started too deeply into EDA, I'll give a quick summary review of what Rescale is. Some of you may not be super familiar with Rescale. I haven't tried it yet. But Rescale is essentially a platform HPC experience. And we say platform HPC experience because we combine the entirety of all these software here at the very top, these software packages that enable engineers to do incredible things in their organizations. We bring those right into a single platform as a service application on the web. And we take that and combine that with a huge variety of architectures on the compute side. So that's AWS, Azure, Google Cloud, IBM, and a variety of other smaller cloud service providers and data centers. But what's really cool about Rescale is we take that fully integrated stack and we package that into one really easy, simple to use interface where an engineer can come in and upload an input file, select that software from the huge library, select the hardware or architecture from that huge library, assemble the tool chain however you like, execute that as fast or as cheaply or as efficiently as you so desire. So that's really what the Rescale is all about, creating an experience of computing that is really effortless and is really well tailored to the needs of the day. I'll go into just one little quick zip here on the stack of tools. So if you're not super familiar with the HPC world, you have the application at the very top. That's what you guys live in on a day-to-day basis, a tool chain really. At the very bottom, you have this infrastructure, and in between is sort of just magic. And your IT team will usually handle that, but there's quite a few layers there to make everything work really well. What Rescale does is we take those 12 elements and we just package that all in one simple platform for you. Okay, so I don't want to bury this in too much of a Rescale sales pitch. We'll actually stay away from Rescale really during this discussion, but I just want to give you a quick overview of like where we are and what our platform provides. Okay, so on to the topic today, EDA, Cloud HPC, are we really there yet? And to do that, I want to introduce our very special team member at Rescale here. This is Richard Pa. Rich, go ahead and give us a quick introduction.
Thanks, Robert. So my name is Richard Pa. I'm the semiconductor industry principal for Rescale. Before Rescale, I was with WMC for a little while as product marketing manager, focused on storage for the EDA industry. Before that, I spent 11 years at Synopsys, running the compute platforms program, overseeing the platform strategy for the company. At the same time, I was also chair for the EDA Consortium Interoperability Platform Committee, which also overlooks the platform and operating system needs for the industry.
Okay.
And before that, I had several roles as design engineer, also in methodology and a bit of CAD development. Yeah.
All right, so you definitely know EDA.
Yes, I've been in EDA for longer than I want to admit.
Fair enough. But so give me just a little bit of history. Like, how did you come to sort of a Rescale particular, or really the cloud experience? What sort of brought you to that? Because we all know, like, EDA is not really, cloud native.
Yeah, that's true. So when I was at Synopsys, cloud came about when I was still there, and I was watching it for a little while. And up until, I would say, probably about 2 years ago, maybe 2.5 years ago, cloud and EDA wasn't really it wasn't really a thing, right? We weren't quite ready for it. The cloud wasn't quite ready for us. We weren't quite ready for the cloud. A couple of years ago, I think there were changes in attitude at several customers. Also, maturity of the cloud got to a point where cloud was a real possibility to solve some of the issues we had in EDA.
Okay. And so, given that sort of like time, so why did you want to come to Rescale specifically, or like what was the sort of impetus to jump to here?
So what I saw was around that time, like I said, a couple of years ago, I started seeing cloud as really being something that could help us with some of the scaling issues we're having, right, in semiconductors. I started looking at different companies that were trying to make inroads into that field. Rescale, I thought, was the one that was farthest along, had the pieces that made sense for semiconductor and EDA, and also the experience it had in HPC, in mechanical CAD, in CFD, in adjacent industries, showed that it had the development and the security required that we required.
Yeah, I definitely want to dive deeper into that. So let's talk a little bit now about how some of this got started. So if you think back to the DAC conference, 2011, that era, what really happened, and how have things progressed in like more detail since then?
So DAC 2011, there was a big push for the cloud. I think what happened was folks there kind of saw the potential, but our industry we didn't really dive deep into that, right? So we got all excited about it. We rushed forward into it and found out that that the customers weren't ready and the industry wasn't ready, right? So customers were looking for a level of security that no one in the cloud was willing to provide. And the cloud was relatively immature in terms of security tools available, and basically where just the maturity in general, right?
But at that point, the compute power was there, though, right?
Compute power was there, but we hadn't gotten to the point where we really needed it yet. It was something that would help us with a impending problem, but we hadn't reached that problem yet.
I see.
Right, and right around now is where we are actually seeing that.
So the first major barrier, starting all the way back then, was security.
Was definitely security, right? So starting back then, customers wanted to move forward, and while the engineering teams were very interested in it, IT teams were interested in it, the risk management people just really weren't, right? And at that point, what they saw was, oh, you could save us some money, but you would risk the IP, which are the crown jewels, doing it, right? And at that point, all the financial information wasn't there yet. All of our personal information wasn't quite there yet. In the last 7 years, what we've seen in the last 7 years is other industries, especially banking and all that, have gone to a cloud-first strategy, right? Where the CIOs are all pushing for this, and the cloud has matured and kept up with those needs as it evolved, right? For our industry, we kind of sat back and kind of did what we needed. Now we're seeing basically CIOs from outside the industry come into the industry, bringing that knowledge and expertise with them.
They're making their careers basically by it.
Yeah, exactly, right?
Sort of modernizing.
Yeah. So basically, we've got IT people from outside industry coming in who already have the cloud experience. They understand the risks involved. They understand the advantages involved as well, right? And security-wise, if you look at it, in the last several years, most of the security breaches have been on-prem security breaches, right?
That's not something that people really wrap their heads around.
That's true, yeah. But if you look at it, the last few security big ones have all been on-prem infrastructure. The ones where you have seen cloud breaches have been situations where folks have misconfigured their cloud.
Yeah.
Right. And the thing is, the cloud is a little bit different than on-prem. You can't wall it off like you can your own infrastructure. So you really need guys who know what they're doing. They need to be experts on the cloud. They need to be experts on cloud security. Right. You got to do it right. And the testing, the testing involved in that, the building involved in that is non-trivial. Right. So if you were to go to the cloud, if a semiconductor guy wants to go to the cloud, they really need to have people that either understand it or go onto a platform that's battle tested, right? And that's what Rescale brings to the party. It's a battle tested platform.
Yeah. So if you guys in the EDA world are not too familiar, but Rescale, I'd say maybe 50 to 60% of our customers are in the aerospace industry. And aerospace is one of those industries, sort of like banking, where redundancy is super important. 15 nines of uptime is also very important because obviously you need that plane to not go down, and that's how you get to the level of sort of safety for say consumer flight or for defense, that sort of thing. So coming from that direction is probably right in terms of building the right level of security from the ground up.
So you had asked me basically what were some things that attracted me to Rescale, right? That history in aerospace was one of them, right? One of the things that coming from semiconductor industry, you realize that semiconductors got its start a lot of its start came from the military defense area, right? So the security involved, what we've evolved from, has been very much that kind of that kind of environment. And even now, some of our more secure customers are the national labs. They are the aerospace and military contractors of the world, right?
We won't name them, but yeah.
Yeah. But at the end of the day, Rescale, in serving the adjacent markets, have built up security that has given it things like HIPAA certification, given it things like Rescale can do ITAR, right?
Yeah.
ITAR is something that we in Semiconductor understand because we have folks that do ITAR as well, right?
Yeah.
So the fact that that level of security exists on the Rescale platform gives semiconductor folks more assurance that their IP will also be safe, right? And that's probably the largest barrier to getting onto the cloud, is basically understanding that the IP will be safe in that environment.
Okay, so let's assume for a second that a customer or somebody who's like thinking about trying cloud doesn't have that security issue. Like, what is maybe a more technical reason they might want to explore cloud HPC as a solution for their sort of EDA tool sets?
So there are a couple of types of customers in EDA, and everybody's facing the same sort of problem. And that's basically the question of scaling to meet demand, right? Moore's law, if you look at it, Moore's law started out saying that the number of transistors in any on a square footage or square inch of silicon will double every 18 months, right? What that really captures is basically the trend that more and more functionality, which was expressed in terms of transistors back then, will fit into the same cost, which was back then expressed in the area of a semiconductor, right, over time. So right now we're saying basically the capability kind of doubles every 2 years, right? And that type of scaling because you're putting more functionality in it, and because basically as you move forward, you're shrinking the geometries, right? Things that didn't matter before matter. Your design rules double pretty much, right? Every geometry you move forward. Well, actually, more almost 10x's.
But we're reaching a physical limit at some point, right? They can't make.
We are. But even beyond Moore's law, what you're getting is that we're coming up with different ways to scale, right? To keep that increased functionality curve within that cost model parameter, right? And what that means for infrastructure folks is that the trend we're seeing is that every 2 years, the impact of infrastructure doubles. That means storage doubles, the amount of compute required doubles, right? And when you're having that doubling of requirements every 2 years, while you're still on a 3 to 4 year depreciation cycle on your compute, right? That doesn't match up. And basically, everybody's facing a situation where they need more compute power than they have on site, right? What the cloud allows you to do is, rather than try to onboard all this stuff that you're going to have to hold and depreciate over 3 or 4 years, right? You can get the latest and greatest compute on the cloud when you need it, right?
It's not really something people associate when they think about like Moore's law. They think, okay, it's transistors, but they're not looking at cost footprint.
Right.
They're not looking at, how are they going to actually achieve what they need to do. And I think it's pretty safe to say that the simulation complexity has sort of kept up, or maybe even led that complexity rise.
So the amount of verification you need to do to keep up with Moore's law is increasing, and probably more so than any other area, right? And that's where I think the cloud and Rescale in particular can really, really shine, right? So when you approach tape out, which is basically a hard line in the sand time-wise, right? Right before tape out, typically 2 to 4 weeks before tape out, you have a huge amount of verification activity because you do your final verification before the chip goes to manufacturing, right? At that point, what a lot of companies do is they go to IT and say, I need 200 more systems, right? Mm-hmm. And IT will go and scrounge out additional systems. So they'll bring up stuff that they've retired, they've held back, they'll borrow from other groups, things like that. They kick everybody else off the environment, and then
it doesn't make them very happy, does it?
It doesn't, right? It is very disruptive, right? And then what you'll do, you'll go to your simulation vendor and ask for 200 licenses for 2 weeks, right? To use up those extra compute you've got, right?
So let me ask a question for those of you in the line, and like I said, feel free to participate or not. But how many of you out there have dealt with this issue that Rich is talking about, where you have a particular workload that's pretty important to your group or to your team, and you're forced to sort of take a seat in the bus, basically, right? Like you're not getting that done right away. I'll ask that. Feel free to answer in the chat. We'll come back to it briefly. But keep going. Tell me more about the kinds of hardware and whether or not the tool chains and the workloads that people are running are really well fit for the hardware architectures they're running on.
Well, so getting back to basically where what I was talking about in terms of the burst workloads for the cloud, right? Mm-hmm. So that's how things are typically done today, right? What going to the cloud buys you is the ability to not have to force IT to bring all this extra stuff in, right? You can go to your cloud vendor, and because the cloud pretty much provides infinite compute, right? You go, instead of getting 200 licenses for 2 weeks, you can go and get 400 licenses for 1 week, right? Go to the cloud and run those 400 licenses. Because typically what you have is around, when you look at your tape out workload, mm-hmm. you've got verification that you absolutely have to do, mm-hmm. A bunch that you want to do, mm-hmm. stuff that you should do, and stuff that you'd like to do, right? And what you wind up doing is that you wind up getting the first 2 buckets taken care of, maybe a little bit of the third bucket, right? Mm-hmm. But your additional code coverage you never really get to because you just run out of resources, run out of time.
And that's where, my cell phone will act very strange in a very particular situation. Right?
Potentially.
Is that a stretch?
Potentially, but basically, you're never actually done with verification, right? So no chip is 100% verified, right? And that's because verifying every single corner case is impossible. There's not enough compute around to actually do that for any particular chip. So verification engineers are very good at determining what has to be tested, right? What matters, what doesn't, right? And then, but no one's perfect. Every once in a while, something slips through, and that's where the final verification comes in. You run as much of the stuff as you can, and you prioritize your jobs based on the likelihood it's going to find something. And the good thing about logic verification is you never have a job that runs more than a day or two at the most, okay. Right?
Even on a big system?
Even on a big system, right? Your critical path job is a day or two at the worst. Okay. So if you compress that time from 2 weeks to 1 week, you'll have all your simulations that you have to do done. If you don't find anything, great, right? You have you give those extra licenses back, but what you didn't have to do is you didn't have to take everybody else off the farm, right? Because the other folks that were running, if they weren't running simulation, they can run on the resources you have. You just push onto the cloud a little bit more, right? So you don't mess up the schedules of the other groups, right? IT doesn't have to bring in systems that may be slower than what you can find in cloud. That by running on the cloud, you can get the latest, greatest systems. You run your licenses more efficiently, right? Which means you get more work done as well.
So let me ask you, how sensitive really are the tool chains to the hardware they're running on? Like I can tell you from computational fluid dynamics, finite elements, very sensitive to the actual hardware you're running on. Is that true for an EDA workload?
So EDA workloads pretty much run on x86, right? We've standardized on x86, and that's basically all we have on there, right? So the cloud is very well suited for the existing EDA workloads because, again, they're x86 systems, right?
But there's a lot of, I mean, there's a whole industry of compute architecture variety out there. I mean, it's not just x86. There's, there's a whole bunch of buzz around GPU, even FPGA. Talk to me about like some of those sort of architecture types, and are they going to be suited? And is that variety really helpful?
Today, not so much, right? Because pretty much all EDA tools run on x86, as I said. But the industry is looking forward towards more of the machine learning areas, right? And in machine learning, especially some of the newer stuff coming out, is focused on GPUs, focused on specialized processors. None of that exists in EDA, right? So as machine learning tools roll out, if they're leveraging non-x86 architectures, there is going to be a delay for EDA to adopt them because those don't exist in EDA data centers, right? The advantage, they do exist in the cloud. So if you want to take advantage of them, you can take advantage of them in the cloud much more readily than trying to onboard all the stuff into your environment and integrating it.
So let's say Synopsys or Ansys comes out with a machine-ready tool chain. They can sort of right away try that out on a GPU in the cloud. They don't have to go to their IT administrator and wait and see, okay, can you guys get a P100 Tesla or whatnot, right?
Yeah. So basically, the other advantage of having of a company like Rescale is that we are looking at industries outside of EDA, and those industries are pushing us forward into the other architectures faster. At that point, we onboard those other architectures into our platform, and they're basically ready for EDA whenever we get there. Right. So that's another advantage of a company like Rescale, where they specialize in scientific computing, right? So that covers areas like genomics, covers areas like oil and gas, aerospace, etc., where other research is being done that we haven't gotten to yet in semiconductor, right? And that groundwork is going to help us get there faster.
That's fascinating. I'm going to open it up to the audience here. Any questions for Rich or on a particular topic? I know that jumping to the cloud may not be everyone's sort of cup of tea, but like go ahead and let us know what your maybe number one concern is. If we didn't already cover that, we'd be happy to bring that topic up. While you guys enter that, I'm going to give you a quick demo on how you can get started on Rescale just to try it out. Let me just punch out the presentation mode here. So if you don't already know, Rescale.com, it's the platform sort of homepage, very easy to navigate to. To create an account, you just sign up. It's free to sign up. And when you sign up, you will see sort of this login page here, this platform. What I've done here is I pulled up a quick view of what the Rescale platform looks like. As I mentioned in the Rescale experience slide, you have an input, you enter software, you choose your hardware, and then you submit your job. There's a huge library of software tools and tool chains available here. We've pre-filtered them for the semiconductor industry, so it's not quite EDA, of course. But here's just a quick view of what's available currently on the Rescale platform. Just want to point that out. Okay, and we have a question coming in here. And the question is from Richard. Data transfer and cost containment is our #1 concern. Rich, can you address Richard's question?
So data transfer, basically, you're concerned about security data transfer. We do provide a secure pipe to bring data up and down. Depending on which workload you're doing, you may not need that much data, because if you're only running for logic simulation, you're only running the execution portion of it. You don't need to bring all the libraries up there, and so your transfer is much more limited, right? The second part of the question was
cost containment.
Cost containment, right? So again, Rescale being a platform that has serviced a lot of engineering companies, we've built in limits in place that the administrator from your company's administrator can limit the time run, cost run, and how much any one engineer can run, how long any one job can run, all of that stuff, all those limits and metrics are built in, right? So you can't control the cost. You're not gonna have to worry about an engineer going in there and going nuts, right? Because you can contain how much they're going to run.
You can also limit the type of architectures they run on.
Exactly, right. You can choose basically which architecture they run on, and each of those actually have a different cost, right? You can limit all that for your own engineers.
Yeah. And I think that budgets and sort of cost strategies, like Rich was saying, very important. We've developed some really nifty tools, both hard limit budgets and soft limit budgets. Definitely try out the platform and go explore that. I could show you now. I don't think I have administrator access on my demo account here, but no, I don't. But it's very, very, very straightforward to do. Again, it's SaaS platform delivery. So if you look at your HR administration platform, when they merged over to a SaaS platform, much easier to handle that sort of thing. This is very similar in that regard on Rescale. Any other concerns from folks on the line? And while we're pulling that up, I'll go ahead and show you where you can find information about how to try out stuff on Rescale. So I'm not going to give a demo. There's plenty of other resources available to check that out. But what I want to show you really quickly is where you can find some documentation on the Rescale site, right here under documentation. And if you look to Ansys resources, you'll see very quickly some of these are already built for EDA. So there's HFSS. I believe there's also an IcePack one in there. We're working on others all the time. So definitely check that out. It's really straightforward if you look on the tutorial or the example. Once you create an account in Rescale, you can just import the job setup. So in one click, it will take me right back to the platform, preload all the input files, and you can sort of get a walkthrough on how that happens. Here it is pulling up here. So we're almost out of time here. If you have any other questions, I would definitely encourage you to reach out to us personally. There's a bunch of different resources and ways you can do that. You can reach out to Rich directly. I believe his email is rpaw, R-P-A-W, @rescale.com. You can always reach out to info@rescale.com. We'd be happy to talk to you. There's a variety of ways to engage more. If you didn't already see, last month, I believe, we did an EDA demo with another one of our solution architects in the EDA space, Riaz Liakov. So definitely check that out. It's available on our website, also in our newsletter. I should also say that this recording today will also be on this month's newsletter, so definitely check that out. Again, I really appreciate everyone's time. I hope you find this interesting. This is sort of an experimentation format-wise on our side. But again, wish you guys a very, very happy week. I want to thank Rich quite a bit for talking to us today and really helping us sort of dig through EDA. I know it's sort of a developing industry, especially for cloud. So thank you very much for your time, guys, and we will see you next time.
Thank you.
Bye-bye.